So we talked about stromatolites as being the earliest macroscopic life, but we have more in our toolkit than just macroscopic fossil hunters. We also have isotopic analyses. This is a zircon here, and inside them you can see these are carbonate granules. And when you analyze these carbonate granules, you find something about the isotopes of carbon. There are isotopes of carbon. Carbon-14 is radioactive with a half-life of about 5,000 years. So that's not interesting because we're talking about 4 billion years here. The stable isotopes are carbon-12 and carbon-13. And why is that important? Because life here. Here I got some life. When you analyze the carbon in this life, you will see that there's more carbon-12 than there is carbon-13. So life in general has that property that it likes carbon-12 more than carbon-13. Your body is the same way. So if you go look inside of a zircon, and zircon are very refractory, very well preserved, and they can date them with uranium lead dating, and they say, oh, we have a 4.1 billion year old zircon, which luckily happens to have a carbonate granule in it. The bottom line is life prefers 12 to 13. Therefore, organic carbon with a low 13 to 12 ratio, i.e. there's more 12, can be evidence for life. Therefore, we can check the 12 to 13 ratio of the carbon. And when we do that in 4.1 billion year old zircons, the carbonate granules inside them, we find that it is light carbon. It is more 12 than 13 than you expect. And that is controversial, but suggestive, maybe pretty good. We debate about this. The earliest evidence for life on Earth at 4.1. Now, there's also carbonate granules that were found earlier in 1996 by the Moses group, and that was 3.8 billion years old. And so this new paper I'm talking about is 2015. So maybe we'll find even older zircons, 4.2 billion years old. And that's the oldest, at least slightly controversial, isotopic evidence for life on Earth.